gonna draw acceleration diagram. Okay, so acceleration diagram, when we'll draw the acceleration diagram, we have two types of acceleration. One is radial and one is tangential, right? So radial formula was v square by r. So if I choose v, this is the O, r, I'll just put r a little bit top, OB should be VOB here, right? And should be ROB here. Do you understand? Now VOB value is 4.71 square. Okay, divide by this one is, what was the length for that? OB 150 millimeter. So 150 millimeter, I have to convert it to the meter because acceleration unit is meter per second square, right? So 1000. So how much it is coming? 4.71 square divided by 0.15. 147. Right? Let's say 148 meter per second square, right? Good. Now I have another one which is AB, right? AB. So radial of AB. AB is, that means I'm going to write AB square by ROAB. Okay? So what is the AB value? 3.5, right? 3.5 square. What is the length of AB? 600. So can I just directly write 0.6 for this case? Now how much is coming? 20. 3.59. Check it again. 3.5 square divided by 0.6. 20. Okay. Let's say 20.5 meter per second square. Okay. Is there any velocity for A? Radial velocity, radial acceleration? No. Because it's a linear, right? So that means if something is moving straight, okay, something is moving straight, it has only one acceleration. Okay. If something is rotating, then it has two acceleration. Is it clear? Yes. So good. Now I don't know any acceleration for point A, right? Any acceleration I don't know. Okay. I have this R and this R. Leave it. So now we have two R's. So what is the R means? R is the radial one, right? Yeah. Now again, please remember again, same principle. We have to find out the fixed point. Who are the fixed point? O and A, right? So we're gonna fix the O and A. This is the first job. If you miss that job, your acceleration diagram can be solved like your velocity diagram, okay? So always fixed point. So I'm gonna go for first point O. What is happening at point O? Can I say point O, radial acceleration means at point O, this is the link, right? So radial acceleration should go like that. Yeah. That means radial acceleration will be like this, right? Is it clear? Yeah. Again, sir. What is the radial acceleration? Can I have a notebook just to explain? This one, let's say this one I have. If I have the link like that, okay, now I'm gonna get a circle. So what is this? This is the radius, right? Radius of the circle. Radial means it is going the velocity like this way. Okay. Towards the center and come out from the center like that. Okay, okay. Okay. So for this one, the link is OB. So radial velocity should come out from the center. Clear? Yeah. Okay. So now if I want to take that one, I need another scale. If you don't mind, do you have? The idea is exactly the same idea. The same way we're gonna draw all the 90 degrees and then it will give me. So can I say this is my radial? Yeah. Can I say this is my radial? Good. So radial is here. I'm just level it because leveling is very important here. This is the radial for whom? OB, right? Good. Now the rules is, I'm going to write it here. Okay. The rules is when radial finishes, tangential starts. Okay, this is the rules.
At 90 degrees.
90 degree. Okay. Now, tangential for this one is how much? Let's see. Read the question here. It says that the crank means OB, right? Rotates at clockwise constant speed. It says constant speed. That means
V tangent 0.
V tangent is 0 for that, right? So that means no tangent for radial, right?
Yes.
So now what is the length of this radial? It is 148. 148 is too big, right?
Scale it.
So why not you just scale it? Let's say divide by 20. Let's say just divide by 20, okay? This is your choice, okay? How much is coming? 7.4. And there will be no unit once you divide something. So this should be 7.4. It's gonna be tough to put it in. 7, no, I'm lucky. 7.4 is here. Okay, we reached here. So now this value is how much? 148, okay, meter per second square. And then I choose divide by 20 and I got 7.4. If you don't level it, what will happen? So many lines now, right? 3 lines for one. You're gonna get lost, okay? Now here, the idea is what I told you in the, oh, now I have 3 scales, good. What I told you, that total acceleration is radial square, right? Plus tangential square, right?
Yeah.
That was the idea. So once radial finishes, tangential starts, right? So this is the tangential and this is the resultant A. Just like that. Now, if my tangential is 0, that means my A is equals AR, right?
Yeah.
So now, in this case, my tangential is 0, right?
Yes.
So that means this is my resultant acceleration, right?
Yeah.
So can I just like put it A, OB is the final acceleration for that? Clear? Now I have done with my point O. All right. Now I have to look for point A.
So we don't square root.
No,
We leave it as that.
cancel.
Yeah,
Square root
because
cancel.
0.
Yeah.
0, right? So now A, what is happening? A is going in this way, right? That means its acceleration is also this way. Am I right?
Yes, sir.
Okay. Now I'm gonna get the acceleration better. I will use this scale first. Okay. If I'm bringing it like that, it's gonna be perfectly. So this is the only one acceleration. So I'm not gonna draw any dotted line for that. I'm just drawing line like that. It is our acceleration of point A. This is the only one acceleration. There is nothing, right? Now,
You take the same line here and you put it here, right?
yeah.
Okay.
Where do you go? Come, please come. Now this is the important. Yeah, where are you going?
No, it's very hot.
Yeah, I know. I'm also sweating, but we need to finish it, right? Now look at here. I have 3 things. Number 1 is this is for OB, okay? This is for BA, and this is this is the piston, right? So now I got the acceleration for this one, right? And I got the acceleration for this one,
Yes.
which is this one and this one. These two link is connected by whom? This one, right?
Yes.
So now this acceleration, these 2 accelerations should be connected by the acceleration of this one.
Yeah.
Am I right?
Yes.
Okay. So I have to find out the acceleration for this one, and this one has 2 acceleration, right? One is radial, another one is tangential. Okay. Now the most important thing is radial means going towards the center, right? So who is the center for this link? Who is the
Fixed
center
point.
for this link?
Fixed point.
Now I said when you joint it here, this is the fixed point, right? Then you're gonna join this one with this one. Am I right?
Yes.
So now for this one, this is my fixed point. This is my center, right?
Yes.
So my radial should go like that. My radial should go like this, right? And then when the radial will finish, I will think about the tangent. Is that clear? So now, yes.
No, what is the value for?
No, this is the linear one. Linear. We're not worrying about the linear part, right? Only the rotational part we are worrying about now. So now can I say for this AB link, this B is my center? Okay, just I explain how. Now who is the radial one here? My radial one should be like this, right?
Yes.
Like this. But from which point I'm gonna start?
From point A. Point A. P.
Now in drawing the radial, from which point I'm gonna start? This point, because this is the only known point I have, right?
Yes.
I don't know how long is this one, right?
Yes.
So only known point I have is this one, so I have to draw it, start drawing from here. So can I draw the radial? So this is the very lucky, very lucky. Okay, here. So this is the my radial. So this is the radial of whose? Radial of AB. Radial of AB. Everyone understand what I'm doing? Okay, good. Now what is the value of AB? 20.5, which is divided by 20. Once you choose one value, you have to divide the same. You have to stick with the same, right? So now I'm gonna divide it this one by 20. So I'm gonna get 1, right? Let's measure 1. If I measure 1, it's gonna be like from here to here, like that. Is it clear?
Yes.
Good. Now let's write here 20 meter per second square, and I divide by 20. I'm gonna get 1. So I'm here. What is the thing? When the radial finishes, tangential starts. So that means my 90 degree, tangential means 90 degree, right?
Yes.
So my 90 degree, can I say this is my 90 degree?
Yes.
Okay. So I will just distinguish between my radial or tangential, okay? Otherwise, I'm gonna get lost. So now this is my tangential, am I right? So AT tangential for AB. Clear? So now what happens here, look at this one. I draw, let's say I draw radial, I draw tangential, right? And it finishes here. Okay? So now once
Stop and start.
this is my starting point, right? And this is my start point, and this is my stop point, right?
Yes.
So we say like tail to head, and then tail to head, right?
Yes.
And then
Tail
this
to
should
head
be
again.
connected tail to head. So who is my tail here? Can I say this point?
Yes.
And who is the last point? This point, right?
Yes.
So can I say, if I just add them from here, and I'll make it very thick line. So can I say this is my final acceleration? Let's say it's gonna go A. This is the final acceleration of AB.
Okay.
Clear?
Yes.
Now you're gonna measure all the things, and then this is the acceleration diagram.
Same as velocity.
Same like velocity, yes. But
different,
now
radial and
different. When the radial finishes, tangential will start. That's it. That's the idea. Okay. So now you can draw the acceleration diagram for the first problem, and then come back to the second problem. All right.